Let's begin. Today's September 30th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria card 5, 9, 13, 19, 20, and 22. And the puzzle uses the green verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A looks at our first digit, the triangle digit, and will let us know whether its value is an even digit or an odd digit. Criteria card B will take a look at the 3-digit solution and will let us know how many of those digits are 3. Are there no 3s? Is there a single 3? Perhaps 2? Maybe even all 3 are 3. Criteria card C takes a look at our middle and last digit, square and circle, and compares them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D will take a look at our first 2 digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E, again, will take a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. Specifically, there are 3 scenarios. One, where there are no repetitions, as in the example 125, or it could be a double number, where there is a repeating digit, as in the example 112, or finally, it could be a triple number, a single digit repeated 3 times, as in the example 222. And finally, criteria card F, again, takes a look at our 3-digit solution from triangle to square to circle, and will let us know a little bit about the ordering of the digits. Are they in an ascending order, meaning that they are increasing, as in the example 135, or are they in a descending order or decreasing, as in the example 421, or could they have no order? So let's take a look at the example 231. Notice that it goes from 2 to 3, meaning it's increasing, and then 3 to 1, then decreasing. So it's that shift that is one way to define a 3-digit code to have no order. Other puzzles have shown that if you have consecutive equal digits, say for example 225, when you have consecutive equal digits, the fact that it doesn't change, say from again that 2 to 2, is another way to express that a code has no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all the 6 criteria cards we just discussed. And we're going to start off with an initial proposal of 314. So the first thing I want to test is criteria card A. Okay, so the Turing Machine does not approve of my choice. For triangle, I did choose an odd 3. The fact that the Turing Machine disapproves of it is letting us know that, in fact, triangle should be an even digit. So let's go ahead and type that up in our notes. Triangle is an even digit. And since it is even, we can go ahead and cross out all of the odds in triangle. So crossing out 1, 3, and 5. Okay, so the next thing I think I'd like to test is criteria card E. Okay, so the Turing Machine does approve of my proposal. Notice that in my code of 314, all the digits are distinct. Well, that falls under the no repetitions, and the Turing Machine approves of that. So let's go ahead and type that up in our notes for section E. And we'll say that the solution has no repetitions. Okay, so I think the next thing I'd like to test is criteria card C. Okay, so the Turing Machine does approve of my choices for both square and circle. Notice that I did choose a 1 for square and 4 for circle. And since 1 is less than 4, it is true that Turing Machine confirms that square should be less than circle. So let's go ahead and type that up in our notes in section C. And that again is that square is less than circle. And let's see, what does that reveal about our solution here? Well, if indeed square needs to be less than circle, square cannot be a 5, because if square were 5, there's nothing larger for circle to be. So we can cross out the 5. And then similarly, if circle were 1, there's nothing smaller that square could be. So circle cannot be 1 either. And notice again, one way to observe that square and circle, they must follow along this sort of diagonal, since all the digits for square are smaller than all the digits for circle. Well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice that we did not test criteria card B, where the Turing Machine will let us know how many digits are 3. We also did not test criteria card D, where we compare the sum of the first 2 digits to the number 6. And we didn't really test criteria card F, the ordering of the digits. So could we have a sum of 6 in the first 2 digits? But how would we choose which one it would be? Not sure about that. How would we choose? So we are only comparing square and circle. Let's see. One other thing that I kind of recall from other puzzles is when we have criteria card F, the ordering, and something that's similar to criteria card C. So if we assume that it's in an ascending order, meaning that they're increasing, let's see, can we deduce anything? If the solution is in ascending order, meaning that they're all going along this diagonal, that's ascending, we would be able to assume that square is less than circle, which would make this card irrelevant. What if it was descending? Well, even though we already established that square is less than circle, if we were to assume that it's in a descending order, we would know that square would be greater than circle. I know that seems like a contradiction since we already established what C is. But I think what I'm trying to get at is I think we can perhaps maybe deduce that the solution has no order, because before we even discovered some of these conditions, I think that exercise shows that I believe we can deduce that the solution should have no order. But let's continue thinking about criteria card D and B. So what could the sum of the first 2 digits be in order to help us construct that second round proposal? We could have a sum of 6, but I don't see how we could order. I mean, it could be both 2 or 4, right? 2 is smaller than a lot of digits. 4, although it's smaller than 5, it does exist. So I don't see how. Could the ordering somehow, the fact that it has no order, could that help us out? Well, if it was 2, 4, I'm trying to see, there's no mention of, you either do have, we do know that there are all no repetitions. Oh, okay. Well, if we were to eliminate 3s, that would just leave, the 2 and the 4 and the 5. Maybe we do have a single 3. And it has to be maybe part of a sum. Maybe something like 4, 3 being greater than 6. And then forcing circle to be 5. Perhaps, because obviously if we had something greater than 6, it couldn't be triangle 2 if it would force triangle to be 4. But the fact that we already know that they're distinct, would that help our cause? So that we wouldn't pick square for 4. There is a 3. Yeah, let's go ahead and try that. 4, 3, 5. Okay, so the whole purpose for that proposal was to test criteria card D. So let's go ahead and do that. Okay, so the sum of the first 2 digits is not greater than 6. Very interesting. So let's go ahead and type that up. And that again, we'll phrase it as the sum of triangle and square is either, we'll state it as that it's either less than or greater than 6. Okay, so we know that the sum has to be less than, not greater than, equal to. We just showed that it's not greater than 6. Okay, so we do have lots of options for sum of 6, and well, technically they're just 2 and 4. And for less than, even triangle 4 would work. 4 plus 1 is less than 6. 2 and anything in square other than 4 would work. So I don't think there's anything we can cross out. So let's move on and let's see if we have, I guess let's test criteria card B. Okay, so it is not true that there's a single 3. So that means that either we have no 3s or 2 3s. Well, we can't have 2 3s because there's no repetitions. So we know that you can't have 3. We know you can't have 2. It did not like the fact that there was a 3, because that's what I had in my proposal. So it is, in fact, we can in fact deduce that there should be no 3s. So let's go ahead and type that up. We're going to deduce there is no 3-digit. Okay, so can't have 3, can't have 2. Didn't like the fact that we had the 1 in our proposal. So let's go ahead and cross out all the 3s. So the 1 in square and the 1 in circle. Well, that should help us a bit. Okay, so we have no 3s, and were we safe in deducing that there should be no order? I believe yes. Yeah, I'm going to say that we're going to deduce that the solution has no order. And again, the reason we're able to say, or I'm saying that, is that since if we assume that the solution has no order, has it's in an ascending order, that would definitely state that square should be less than circle. If it was descending, we would know that square is greater than circle. Again, both of those reasons would be sufficient to render criteria card C irrelevant, and we can't have that. So I'm stating that we have no order. So let's see, what can we do next? Should we start listing potential solutions? Yeah, let's go ahead and do that. Well, let's see, there might be way too many. I think we need to, yeah, it looks like we really do need to test criteria card D one more time, because I think it's just way too much. What would be the easiest? That there would be a sum of 6 or less than 6? I think a sum of 6 would work, but what about the ordering? So I guess if it was sum of 6, you couldn't have 2, 4, because that would lead you to an ascending. But 4, 2, 5, how about, well, if it was less than, how would you distinguish if square were 1? You still would have to pick from 2 or 4, and both of those work. So it seems, well, yeah, so it seems like it couldn't be a 1, because how would you distinguish between triangle being 2 or 4? Okay, maybe we can deduce this solution. Well, let's see. If it can't be a 1, I guess technically it could still be less than, well, it could be less than with, no, it couldn't be less than with 2, 2, because no repetitions. So it looks like it would have to be 4, 2, 5. Can that be it? 4, 2, 5? Yeah, no repetitions. Yeah, it looks like that's, again, assuming we are correct that we deduce that the solution should have no order. Yeah, I'm gonna go for it. So I'm gonna say the solution is gonna be 4, 2, 5. And well, let's go. I mean, it seems, yeah. Well, let's do a quick verify here. Is the first digit an even digit? Yes. Are there no 3 digits? That's right. Is the middle digit smaller than the circle digit, the last digit? Yes. I'm deducing that the sum is equal to 6. So we'll move on. And no repetition, that's correct. And again, we deduce that the solution should have no order. And 4, 2, 5 does not have order. So let's go ahead and verify. 4, 2, 5. Okay, wow. Whew. Okay, how do we do versus a Turing machine? Well, we did only 5 tests out of 6 criteria cards. I'm thinking, yeah, we definitely beat it. The question is by what margin? Well, we did do ACE in the first round and then BD in the second round, and we skipped F. So let's go type that up. And that was again ACE. So I think A was incorrect. Both C and E were correct. And in the second round we did B and D, and both of those were incorrect, and we skipped F. Wow, we only beat it by 1. Sometimes I'm surprised. Sometimes I feel like the margin is larger than what it should be, and here it's the opposite. I thought we would have beaten it by 2. But okay, I think it really did help out in being able to deduce. I think this was really what won us, is this deduction that there should be no order. And, even though I didn't type out all the possibilities, it was a little bit evident that square could not be 1, since we would be unable to pick among 2 and 4. So that led me to deduce that the sum of the first 2 digits had to be 6. And then because of no repetitions, well, of course, that led us to circle being 5. So some good, deductions and some luck, obviously. Well, what do you think? How did you solve it? What order of criteria cards did you use? And did you discover anything interesting about that choice? Add your thoughts to the comments. If you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.